All right. First set of problems. I want you to find the quadratic function with the given vertex and passing through a second point. So what this is getting at, um, yeah, let's do part A. So we'll do part A off to the side here. So here's going to be my A. We should be able to, if you think kind of what our general equation looks like, we should be able to come up with most of this by simply knowing what our vertex is. If I know my vertex is 0, 0, that should allow me to come over here and write this as x minus a0 squared. And then since my y coordinate is also a0, I would put a0 on the back end. I can do that just from this vertex. The issue when we wrote the equations is how do we figure out what that a is? The way we figured out our a is you were given a different point. So if I now ask what is the x coordinate of this point right here, isn't that x coordinate a -2? So what we're going to do is substitute that in for the x in this equation. It's a -2 minus a0 squared. The little plus 0, I'm not going to show it. It's really not necessary, so I'm not going to write that back part. At the same time then, if I want to know what's the y coordinate of that point, the y coordinate is an 8. So I'm going to plug in an 8 into that location. We now have a quick little equation that we can solve for a. That's the missing piece of information that we have. So -2 minus a0 is just a -2. And then I want to square that. And then hopefully we all agree a -2 times a -2 is a 4 times that a. Solve that for a by dividing both sides by 4, and we find that our a is a 2. So what we now can do is write this entire equation now, and we would say that y equals, instead of a generic old a there, we now know that's 2. And then we have x minus 0 squared. If you want to put the plus 0 on the end, you can. But since it's a 0, you don't necessarily need it. Okay? All right, we're going to jump around a little bit. I kind of want to make sure we do little different versions of each. Go to letter E. So go to letter E, same set of problems. And what I would hope is if I do letter E, we'll do this one here. And all I give you initially or talk about initially is the vertex of 2, 5. You should be able to come up with a lot of this equation right now. So see what you can write by just knowing that our vertex is 2, 5. Because at bare minimum, we should be pretty good with this at this point. Okay. Not a lot of work. Just write down if we know this is 2, 5. The a we don't know, so that's still going to be there. But if my x coordinate of the vertex is a positive 2, wouldn't that then mean we would have had x minus 2 squared? All right. Then if our y coordinate is a positive 5, that would mean I have a plus 5 hanging out in the back. That hopefully we can do by just knowing the vertex is 2, 5. But then the question is, how do we figure out what our a is? The only way we can do that is if we have another point that goes through the parabola. Well, that's what this guy is right here. So if I now ask you, what is the y coordinate of the other point that we are given? That's a 7. So I'm going to plug in a 7 into that location. We then need the x coordinate of that point. The x coordinate of that point is a 3 here. So I'm going to do 3 minus a 2. So the first point allows us to write it in vertex form. The second point allows you to figure out what your a is. So we now go through these steps to solve for a. So 3 minus 2 is a 1. That's what we're going to square. Go ahead and square your 1. 1 squared is just a 1a. If we're solving for a, you would then subtract 5. So this is me subtracting 5, and what we should get is our A is equal to a 2. Let me move this up just a bit so we can see that. So all we now do is go back to this original equation that we set up from the vertex. Now I can complete this equation by erasing the generic A that I have highlighted because we now know that is a 2. So we slot a 2 in there. That's then our answer. Okay, following this? Okay, then take a minute before we move on to the next type of a problem. Create some space for this one. Do letter F someplace. There's plenty of room for you to operate on there. Now try letter F, see if we can get through one of these on our own. I'll give you 2 minutes, see if we can do this. You have your vertex, that should give you a bunch of it. And then figure out the missing part. You need another point, which is the point 0, 0. As a hint, it's kind of a weird number that you get at the end. So if you get kind of an ugly number, decent chance you did it right. Okay, you got 30 more seconds. And then as you are wrapping up, okay. I'm trying to remember what it was. It's either negative, is it 4 nights or negative 4 nights? Okay. Okay, perfect. Thank you. Okay, if you got this, you did it right. And if not, pay really good attention and see where things would have gone wrong. Okay? All right, so to get this started, if we know that this vertex is a negative 3, 4, then what I should know is that I have an x plus a 3 getting squared, and then I have a positive 4 hanging out in the back. We can get that from just this point, if I know that's the vertex. Our issue is we don't know what number is in front of these parentheses. It could be 1. We've dealt with negative numbers before. We've dealt with 5, 2, 3. That's our letter A. That's what we don't know. So we need more information to find that. Well, that's what this point is for. So this point 0, 0 is actually a nice point. It's hard to screw that up because you just let your y be a 0. You let your x be a 0. And then we just go through and solve that for A. So let the x and the y both be a 0. Then just be careful working your way through this now. 0 plus 3 is 3. So I'm going to do a 3 squared. We should all agree 3 squared is a 9. So that's a 9a plus your 4. And I just flip them so it looks more like what you would like it to look like. Subtract this 4 over. I'm running out of space here. But what I should now get, let me erase this, is a negative 4 on the left, 9a on the right. And then we know if I'm going to solve this equation, the way I undo multiplication is through division. So notice how your A then becomes a negative 4 ninths. So we go up to this original one that we could set up just from the vertex. But what we've now identified is this A right here. I'm going to erase it. We now know that that is a negative 4 over You get that? Hopefully. Good. Say that louder. I still can't hear it. When you divide it, what? Like if you gave me the decimal?
Yeah.
I would take that. The only issue with that, isn't it a non-terminating decimal? So I guess you could put like a negative 0.4 repeating right here. I wouldn't necessarily mark it wrong. I'd rather leave it as a fraction. There'll be some multiple choice tomorrow, and it's probably going to be the fraction version. But if you put this, it's not wrong. Yeah, that's okay. You did the work right. Okay, then skip along here. Go to number 4 where you have a series of things because it's the exact same set of problems. It says find the equation of the parabolas below. Cross this out here. So when it says put your answers in standard form, I don't think I'd make you do all of this in once. We're still going to just put it into vertex form right now. We don't need to go too crazy with this. And we're going to do letter A first. So letter A, this is no different than what we just did. What we want to know to write this is the vertex. So if I look at this parabola, we should be able to know where the vertex is at. So put the point on your vertex. We should all be able to do that. Once you have that point on the vertex, write the coordinates. Is it the point 2, 6? Is it the coordinates negative 4, 5? Write what those points are, or that point is. Once you've done that, haven't you basically gotten to where we started these previous questions? You were given the vertex in all 3 of the ones that we did in this whole set of them. So can't we then go to this first step and write most of this equation by just knowing what our vertex is? All right, do that. So before I do it, see if you can get that far. All right, so 3 things you should have done. We should have put a dot right here. That's our vertex. And then I ask you to label that as a set of coordinate pairs. That should be a -1, 0, right? Do y'all agree that's that point? So that is your vertex. That should allow us now to come over here and know that this should be an x plus a 1 in the parentheses, and then a plus 0 just chilling in the back. So instead of me just giving you the vertex, you would just find it from the graph. Okay, that's something we should be able to do. Our issue though is this little a right here. That's what causes our problem with these, is we don't know what a is. All right, so we need to find that. So in the other one, we needed another point. So now our other point, if I can get my marker to work, we need to find. So if I look at this graph, the point that I can look at that I know the coordinates to, if we look right here at this guy, don't we know the coordinates of this point, since it's going through the y-axis perfectly? Aren't the coordinate pair going to be 0, -3? That's that point. That then means the y coordinate of that point is the -3. So I'm going to plug in a -3 right there. And then the x coordinate of that point is the 0. And then we're at the same spot we were at in the first 3 problems that we did today. We now need to solve this for A. So 0 plus 1 is 1. We're going to square that. 1 squared is just a 1a. That's pretty much your answer, right? A equals -3. That should make sense. The parabola opens downwards, so we better have a negative number in front. So now I just go back to this equation that we had set up at the beginning. I now know that my A is a -3, and then that's our final answer. All right. Yeah.
Does it matter if you use the other point, like -2, 3?
It might. So just make sure you know those coordinates. A lot of the ones I gave you grids, and then the grid is easier to identify a point. So the only way we know this for sure, it wouldn't matter as long as you know that point is on there. The reason we know that is on there, since it's not gridded, if you don't want to eyeball it, The reason we know this point is on here is because we know this point is on here. And if we talk about our axis of symmetry down the middle here, then the point 1 to the left of it would also be fine. So yeah, you could use the point -2, -3, and you would still get that A value. All right, I promise. All right, letter B. Do letter B. See if we can get through that one now. We'll do one more of these. It's the same exact problem we were doing the first three, except you need to come up with these points on your own. Okay, let's see if we got at least the right start. The first thing we have to have is our vertex. So this parabola's vertex is right here. So like the first three where the point is just given to you, you just have to figure it out yourself. That shouldn't be a big ask. All right, that's 1, -3. So with that knowledge, we can write this as x minus a 1 in the parentheses, and then a -3 hanging out in the back. So we can get that from the vertex. To get the number in front, though, this a, we need another point. So to me, I'm using this point right here. That's the one that I know the exact coordinates of. But if we understand our axis of symmetry, so it's USEP's question, then the point 2, -2 would also work. But I'm going to use this one. I'm going to go 0, -2. The y coordinate of that point is the -2. The x coordinate of that vertex is the 0. So we just do a quick substitution with that point. And then go through, solve for your a. So we still, again, have a -1 getting squared. Everything else stays the same. When I actually go through and square the -1, it's just a +1. Everything else stays the same. And then to solve that for a, you're going to add 3 to both sides. And a is a 1. So that's a nice one. All right, so we go back to this a. We just let that be a 1. This is your final equation. Okay? So be able to do both. I can give you a graph, I can give you the points, and we should be able to work our way through it. We've done it with the table as well. So if I give you a table, don't be fooled by that. The way we know in a table what our vertex is you want to find the point. Like if I give you the point 1, 2, then the point directly behind it and the front should have the same values. That's how we would know that this is our vertex. So we've done it all 3 ways. All right, so be able to handle that. Okay, next set. Work your way back. We're just going to do one of these because this was the question that we got asked at the beginning of class from the homework. Go to number 3. No, sorry. Go to number 5, the next set of problems. Or the next, I don't know how I have it numbered. Just go to the next page. Convert in each parabola into standard form. So this was Jackson's question here a little bit ago. So we've already done a couple of these. So we'll maybe do 1 or 2 of them. If I want, this is vertex form right now. I know my vertex is 2, 3. If I want standard form, this is when we actually write this out twice. And then just distribute and combine your like terms. Okay, so that's what we do. I'm going to take x times x squared. I'm going to do x times the -2, -2x. Once that's distributed, take your -2 and distribute it. -2 times x is a -2x. And then this -2 times this -2 should be a +4. And then plus our 3. Combine your like terms. We have a -4x there. We have a +4, +3. That is a 7. 2 I'll leave you. It's a nice one. I want to do one with something in front of it. We'll do 3 actually. So go to number 3. Number 3, we have this little -1 in front. So then we have x plus 3 times x plus 3. That -1 you're going to ignore until the end when we distribute it. So we're going to initially do the same thing we just did. X times x, x times 3 gives us the first 2 terms. And then the 3 times x, and then the 3 times 3. Combine your like terms in there, so we end up with 6 x's. So it's the same as the one we just did, except now this number that we would have had in front, in this case is a -1. Now we just have to distribute that. So now go through, distribute this. -1 times x squared is a -1x squared. The -1 times the 6 is a -6x. The -1 times a 9 is a -9. And then finally our little -3 there. Final answer, -1x squared minus a 6x. And then if you notice, these are like terms right here. So we're going to be able to combine those to make -12. Yeah.
Do we have to put the 1?
You don't have to put the 1. So if you just have the negative there without the 1, that's also fine. All right. Had some of those in the homework. Hopefully that went reasonably well. You'll certainly be asked to do that. So now the last ones I want to make sure we finish with. Now go to number 3, because this is the homework that I just gave you back. Based upon that homework and not seeing how the homework that you did over the weekend went, we needed a little work on this. All right, so these are now in standard form. We want to put it into vertex form. So what we did, so here's letter A. I'll do letter A first. The way we want to put it into vertex form is create this perfect square. So if you're past the point of drawing the squares, congratulations, because long term, we do want to eventually get away from them. And if you're not, and you want to do well in the quiz tomorrow, keep drawing them, okay? So if you need them, use them. So the x squared from this, I'm going to put right here. That means I have x times x. The 4x, we should remember, make up these 2 squares. So if I have 4x total and it's a square, that means I have to have 2 x's in each of those corners. That would then also tell us at the top, I have a 2 here and I have a 2 here. It's a square. It's an x plus 2 on the top. It's an x plus 2 on the bottom. So to make this a perfect square, to finish this square off, I need a 4. Because I would have 2 times 2. All right, so then what we've said is, if I now write this as x plus 2 times x plus 2 squared, when I write it like this, I end up with 4 constants, right? That's how many I have in my square. How many constants did we have in this original problem hanging out at the end? It's actually kind of a trick question. How many were back here? None, right? It's a 0. So what do I need to do to 4 to bring it down to a 0? Minus a 4. So that would then be our vertex form for that equation. Okay. Or what we've been saying as well, if I know there's a 0 right here, just take the constants and just do that number minus it from that 0. 0 minus 4 would also give you the -4. Okay. All right. The next one I want to do, let's do letter B. So x squared minus 2x plus a 2. So now we do have a number hanging out in the back. If we do our little squares, we know we have one x squared only. So that's our x and our x. We know these 2 locations here and here have to make up the -2x. So that would mean I have to have a negative 1x in each to give me the negative 2. So that would mean I have a negative 1 on the top and on the bottom. To complete that square, negative 1 times a negative 1 is a positive 1. So when we now go to write our answer, what we have is an x minus a 1 times an x minus a 1. So we write that as x minus a 1 squared. And then it's up to you how you want to think of it. If I currently have one constant and I need two constants, then I'm going to add one. All right. Or just subtract that one away from the 2. All right, then we get to, let's do letter E next. I think letter E is, even though it's the last one, the next nicest one. All right, because these now is when we started to say we may not want to be drawing these boxes in, all right, because the boxes start getting a little bit trickier when we start adding 2 of them, 3 of them, 4 of them. So what we talked about is we always want a 1 in front of our x squared. These already had 1s in it. So there was a 1. This number 1 had a 1 in it. Well, if I want these to be a 1, then I need to divide that x squared by 2. All right. That then is the number that goes out in front of our parentheses. And then what I am left with is just x squared, because these would have canceled. And then the negative 8 divided by 2 is a negative 4x. And then what we did is we made that into a perfect square. All right, so what I want you to do is if we drew in a box, write down what the bottom right-hand corner would be if I drew in a box with an x squared and a negative 4x. So if we drew that in, if you need to draw it in, totally fine. So draw it in if you need to. Upper left-hand corner is x squared. The other 2 are negative 2x's. And then what would that bottom right-hand corner have to be? All right, Hannah, what do you think? Good. That has to be a plus 4 if we drew that out. Well, notice how we just made that up. We just added that out of nowhere. So this is where on the back end we said we can't just add 4 out of nowhere. We better get rid of it elsewhere. Otherwise, we've changed the problem. And here's where some of us are having this little problem on Friday. We're not just subtracting a 4, though, here, correct? Because don't we really have 2 4s because it's being multiplied by 2? So it's not just 1 4, it's 2 4s. And 2 4s is how many? 8. So we're going to subtract 8. So what I would then have is 2, and then I would have had x minus 2 squared, and then our constant at the end is a 1. All right. All right. I don't know if we have enough time to do another one. What? Oh, it is 25. Yeah. Like, why do I always think it's 20? Thank you, Mr. Krubitz. Well, just don't pay attention to this one, Henry. All right, go to letter C. So let's do letter C next. Now, when we go to letter C, look at that, how that is in the wrong form or wrong order. So what I'm going to do when I rewrite letter C, we want the square term to be first. So put the negative x squared first. Then we want the 6x to be second. And then the number that's all by himself, the constant, he always goes at the end. So then it's in the right order at least. The negatives are the hardest. Just like that previous one and the previous couple, we want a positive 1 in front of our x squared. So that's why I divided this by 2. Right now it is a negative 1. So we're going to divide that by a negative 1. So basically whatever number is in front of it, if it's not a 1, we want to divide by it. That means the negative 1 is what's out in front. And then that gives us our x squared that we want. 6 divided by a negative 1 is a negative 6. And then that's our x. And then we still have the minus 10 in the back. All right, so now fill in that square. So if you need to draw it, feel free. But what would make, if we made a square, what would be the bottom right-hand corner? All right, see if we've got that part down. All right, if we made this a perfect square, so again, let me draw it. Oops, I don't need the big one. So people understand where this is coming from. The x squared is here. The negative 6x's mean I would have had negative 3x's here and a negative 3x there. So wouldn't it be a 9 that finishes that off? Because I would have had an x and a negative 3 and a negative 3. So that would have had to have been a 9 in the bottom right-hand corner to finish off that square. So I'm going to add 9 to this. So now this is us adding something that was not in the original problem. We can't add something that's not in the original problem. So I want to subtract away what I just added. So if I added 9 here, I would subtract it over here. However, this is not, we're not doing minus a positive 9, right? Because this negative 1 is being multiplied by that. So this is really a negative 9 that we are subtracting on the back end. So final answer. The negative 1 is in front. I had x minus 3 times x minus 3. So that is an x minus 3 squared. When we now do this out here, this is really a negative 10 minus a negative is the same as adding 9. So we then get a minus 1 on the back side. This is our vertex form of that parabola. That is pretty sneaky. That's pretty tricky. All right. All right, now go to the last 2 pages. There's no work there, or there's nothing for you to do necessarily. But if you want some worked out examples that kind of walk you through what we just did for you to kind of look off of and study, this is us going from standard form into vertex form with the work. Same thing here. This is standard form into vertex form. If you look at the ones on the bottom, this is us going from vertex form into standard form. Okay, all the work is shown there. Same on the next page. These are the ones that homework I just gave you back that wasn't real good. This is standard form, and then all the steps worked out to get you down into vertex form. So just something for you to kind of model and look at. If you have any questions, see us tomorrow. I think I'm full.
I'm not full.
Wait, wrong one. Yeah, but Mr. Kubowitz has some openings. So if you're not squared away on all of this and you need some help, sign up, see Mr. Kubowitz tomorrow. It'd be perfect to go in their second period, get squared away, come right in here while it's all fresh in your head, and then be able to take that quiz. Okay?
If you sign up for me, I'm in C208.
Oh, and then stop recording.